Hi everyone, this tutorial is about the latch, and then the next tutorial will be a continuous tutorial on the latch enable. Now D-latch is an electronic device that can be used to store one bit of information. The D-latch is used to capture or latch the logical level which present on the data line when the clock input is 1. If the data on the uh, data line changes state while the clock pulse is 1 or high, then the output Q follows the input D, when which we're going to have a look at that in a minute. So when the clock input falls to logic 0 or low, the last state of the D input is trapped, or we say frozen and held in the latch. That's why it's called D latch, as in data latch, latches into the bit. So we have something here called characteristic. So when L is, if we look at this bytes table, if we have L is 0, then Q is frozen. And if L is high, then Q equals D, which we'll have a look in a minute. So D latch does not have clock, while D flip-flop clock input. So this is one of the main difference I explained before, the difference between the flip-flop and the latch. So as I mentioned in the previous tutorial, flip-flops are edge triggered and latch is a level triggered. So what that means, level triggered, the output can change as soon as the input changes. Or the edge triggered, it only changes when the control signal goes from 1 to 0 or 0 to 1. Okay, so it's worth looking at the previous flip-flop tutorial. So back again to the D latch here. So as I mentioned earlier, when L is 0, then Q is frozen. And when L is 1, Q equals D. Okay, so let's have a look here. So here we have the input L is 1. So the L is 1, then Q equals D. So if D is 1, then Q is 1. And if we look at the clock diagram here, as you can see, because the previous example we started from where D is 0, so that's 0, and L is 1, that's high. Okay, that's why we say high and low, because in terms of the diagram. Yeah, so if you look at the previous example, when we have L is 1, then Q equals D. So in this situation, we can like start with 0, which is low. So let's have a look here. We have L is 1, D is 1. So L and D are high. L is already was on high previously, so it continues high, while D goes up and Q is 1, which is high. Now, if L is 0, so according to this law, if L is 0, then Q is frozen. But because we came from 1 in terms of the Q, which is high, then it freezes, stays as it is. And let's say if we have L is 0, D is 1, Q is 1 from previously because we had it high. And if we have D is 0, L is low as well, then if L is equal to 0, Q is frozen. And L here equal 1, that's when we say Q equal D. But we can't say here Q equals D because L here is 0. If we have D is 0, L is high, then Q equal D. So you won't go wrong if you follow these characteristics. Yeah, by following these simple steps, you will be able to understand how the bytes table works. In terms of the diagram here, you just follow up and down. If you watch my previous tutorials on clock diagrams, then you will understand that we are just basically following the input and the output. And then here, if we have D and L 1, then because D is 1, L is high, then Q equals D. So let's have a look at this. We have here 2 AND gates, we have NOT gate, and we have the bytes table here. And then here we have the input D and the input L. So as you can see, because I have 2 AND gates, so I have one here and the second one there. And then we have the set, the reset, and the output. And this is, you should know it by now, the clock diagram. So here we have the truth table, two truth tables, because we have two AND gates. So here, if we have input 0 for D, and L is 1, so L is 1, and D is 0, so L goes in as 1, and then 1 into also the first gate, and then if 0 is equal to 0 here, goes into the first input as 0. However, we invert this into 1 when it's going to the first input of the second AND gate. So here, then we have 0 and 1 coming in. So here we have 0 and 1, and then 0 and 1. And if it's 0 and 1, 0, 0 and 1 is 0. But in this situation, we have 1 and 1, so that's the output would be 1 in terms here of S and R. So let's have a look. So if we have here, L is 1 and D is 0. So goes in as 0, comes out here terms 0, because here we have the second input is 1. And so 0 and 1 is 0. And here 1 and 1 is 1. So as you can see with this truth table here, we're looking at the output in the end. So we're not doing the truth table for A and B if you watch the previous tutorials. So here we have the 1 from the L and the 0 from the D. So R is going to be 1 because just we have 1 and 1 is 1. So R is 1. Now let's find out S here is 0. Why S here is 0? Because we had, as you can see here, 0 and 1. We have a 0. But as you can see, the L is 1 and the D is 0. So my S from here is going to come as 0 input here. And if I want to add the Q here in my diagram, you can see for the bistable is 0, so it's low. Let's take a look at another example. Here we have D is 1 and L is 1, and then we get Q1 if it's basically L is high. So let's have a look. Here we have D is 1, comes in as 1. L is 1, comes in as 1. 1 and 1 is 1. So here I'm going through to the S, which I'll show you that in a minute. Now here 1 comes in, invert to 0, and then this is 1. So 0 and 1 is 0. So let's have a look at the L is 1. The D here is 1. So my R is 0. And when we have L and D 1, my S is 1. And then here my Q, because now we go to this rule, if L is 1, Q equals D. I know D is 1, therefore my Q will be 1. So Q is high, while L was high from the previous example. And then you could see D because it was 0 up there. So now it's gone up because it's 1. So let's have a look here. As you can see here, my L is 0. On my D, for example, here is 1. Yeah, then you just work the AND result into the S, and then you add it into your truth table, and the same with L. And then, for example, I have 0 and 0. Then we go here to the rule, which is if L is in the bistable here is low, then this one frozen. Q is frozen. So because previously we had Q is 1, so therefore here stays as 1 due to my input from L is 0. Let's have a look here. Here again, we have both D and L 0. So the rule says if L is 0, Q is frozen. So regardless, my input here is 0, still stays frozen due to the L is low. So let's have a look at this example. So we have D is 0, L is 1 this time. So I know now Q is going to equal D. So let's have a look. So I have L is 1, as you can see the first truth table. D is 0. So when we have 0 coming in, 1 is 0. And then here when we have 1 and 1, we know is 1. So my S, my R here is 1. So when 1 and 0, when we have D is 0 and L is 1, I know it's coming here as 1. And then for my S again here, my 1 and 0, L and D, or D and L here, we know we have the S is 0. So when I have my bistable here is coming in into the R as 1, then Q equals basically D, and D is 0. Here, let's have a look at another example. We have both ones, both high. Coming in, we have 1 and 0. So when we have the D is 1 and the L is 1, we know R is 0. And then when we have D and L here is 1, we know the S coming is 1. And then because this one is 0, and then Q frozen because previously we had Q as 1. Yeah, so Q here in this situation equals to basically frozen because we had it from the previous input. Because here I'm kind of skipped this section. Okay, so always we follow this rule. Yeah, because here, as you can see, Q equals 1. Okay, so I hope this helps you with this tutorial. Next tutorial will be talking about the D latch with enable.